Hello there. Today we are going to take a look at arrays, managing data into groups as opposed to just having individual variables for everything. And we're going to start off with a pretty simple example where we want to create an array of 5 numbers, print them out, and print the sum. So in this we're going to need to figure out how do we make an array, how do we iterate through each element, access each one of them one at a time sequentially, and how do we do something with those elements as we access them. So let's take a look at that. Okay, so we don't really need to import anything. Arrays are built into C++, so there's no libraries we need to add. We need to create an array of 5 numbers. So to create an array, we can do int my array. We need to specify how big it's going to be. So in this case, we want 5 numbers. And then we're going to set up what those numbers are. You don't have to do this step of setting up what they are. You can have an array that has is just defaulted to nothing, but you should either initialize them right away, or you should perhaps use a loop that will set the array values to be something. In this case, we'll keep it simple, and we'll just say, 10, 20, 30, 40, 50. And if we're going to calculate the sum of all of these, then, int sum starts at 0, and we're going to increment it over time. Something I should remind, just because I've been handling a lot of the test 1 remarks, it's really important that anytime you initialize an integer value that you want to start at 0, that you make sure to specify it's 0. Some compilers will make things fortunate for you and automatically set the value of this variable to be 0, but this isn't actually the case all the time. And if I were to execute this, for instance, on my computer using Linux, it's not guaranteed at all that the default value of sum would be 0. It could be anything. It's just some place in memory that may have had some value already associated with it. So to be extra safe, you always should initialize something to be 0 if you need it to be. Now, let's just make sure this works. I don't have any syntax errors. I think we're okay for now, though. So now I want to print each number and then print the sum. So we need to go through each element of the list. So we need a loop for that. There are 5 elements, and we need to go up every time. We want to print each one out. So to access an element of the array, we need to use the square brackets here. So we're going to have my array, and the element I'm looking at is the ith element at any given iteration of this loop. The first time the loop goes through, I is 0, so I'm looking at array element 0, which is the 10. Then I have element 1, which is 20, all the way up to element index number 4, which is the 50. But you'll notice that there are 5 elements. 4 is the index of the last one. Now, I want to print this out, so I'm just going to print it out. A new line. But I also want to increment my sum. So my sum is going to be incremented by that same value. And finally, I'll print out the sum. And let's make sure this works. 10, 20, 30, 40, 50. And the sum of these is 150, which sounds perfectly cromulent to me. So that's all that we need to do. But this is the kind of process that you're going to need to get very comfortable with. Setting up an array, being able to process each element of the array, do something with it. In this case, we're keeping the processing pretty simple. We're just adding everything to a sum. But there may be more complicated things you have to do later down the line, where every part of this array needs to be part of some bigger problem that you're trying to solve. Getting used to being able to go through each of these elements and do something with them is a skill that is going to be very valuable to you. So next we can move on to the next problem. Okay, so create an array of 5 strings. Prompt the user for 5 words and put each word in the array, then identify the longest word. Okay, so if we need the longest word, we're going to need to definitely use the length method of strings. We're also going to need to make some changes to the code we have, where first off we need to actually prompt for all these words and fill them in. Now, so let's just take what we have already and we're going to make some changes. So we're not outputting, we're not going to have an int array, we're going to have a string array. We're not going to have any default values because we need the user to fill them all in for us. And we don't really need a sum, but I suppose we do need to know what the maximum length is. So initially it'll be 0, and we'll get them to be bigger later. Now, I need to get something to put into my array. So For this, you're going to want to use getLine, and the reason for that is that somebody's string might have multiple words in it, and if you use cin, they're only going to be able to take one word. You might want to be able to take a lot. Does this actually say five? Oh, it says prompt for 5 words, so I guess cin is okay. Let's do getLine, just because we've been using cin for most of this course, and it's nice to see a little bit of a change. So we're going to getLine. The source is going to be cin, and the place we're going to put the data is into my array at index I. So now we have the string that they typed in. All we need to do is figure out if the length is something we need to adjust. So if the length, which is the biggest length of anything we've seen so far, is less than the length of this new element, which is my array I dot length. So this will give us the length of the string located at element I, which is the thing they just typed in. If this condition is true, it means we found a longer word than we had before, and we can update the value of length to be this new number. And finally, the length of the longest word is the length. And let's see if this works. I hope so. Okay, I probably should have prompted them for words, so that's, I guess, one thing that I'll fix, but just to make sure the rest of this is working. So I got a word, longer word, longest word, a short word, and then none. The length of the longest word is 7, which is how long the word longest is, so I think we're doing this correctly. And now, just to make things extra nice, we're going to make sure we prompt our user. Please enter a word. Colon was here. I suppose I don't need the end line. Just to make this a little bit cleaner. Please enter a word. Word, word 2, word 3, word 4, and very long string. Very long string has 16 characters. Is that right? 4, 8, 12, 16, yep. And there we go. Not too difficult, but a good chance to practice our use of the string methods, practicing getLine, practicing length. And in this case, we didn't really have to change too much to go from an integer array to a string array, but this time, instead of initializing all of the values, we processed them from the user. So this is a case where we didn't know right away what all the values of the array were going to be, but as we go through each element one at a time, we can fill them all up and figure that out. So that's our next exercise done, and we can move on to number 3. Okay, number 3. Create arrays of various sizes for each of character, double, integer, string, and float. Output the size of for each of your arrays. What do you notice? Figure out how to use the size of function. The size of each array to determine the actual size. And as a hint, you can try, what does size of int do? Well, let's find out what size of int does. So we're going to use our classic refactoring techniques here. So this was exercise 2. And we're actually just going to take all of this code and we're going to put it into exercise 2. So that way, if we ever want to run exercise 2, we have a function for it, but we don't really need it. Right now, we just want to know, what's the size of the integer? Size of int. Let's see what this gives us. Size of int is 4. Kind of interesting. So what this means is that in your computer, all data is represented by bits and bytes, bits being 0s and 1s, and a byte being a collection of 8 bits. Now, the different types of data that you have can be represented with different amounts of bits. So, in this case, this is 4 bytes represents 1 integer. So if you do the math, it turns out the biggest integer you can have is actually a pretty sizable number. Let me see if just Google what the size of is. It's something pretty big. C++. What's the size of maximum integer value? It's some like huge number. Yeah. So two. What is that? 1 million. So 2,147,000,000 4,483,647. That's a pretty big number. And to represent that, you actually need 4 bytes to do so. And the reason that this is the number that you end up with is because if you take all of the bits in those 4 bytes that you can use and you just set all of them to be 1, what you effectively have is 2 to the power of 15 is, I guess, the biggest one. So that's, or sorry, not 2 to the 15. It's 2 to the, what is the value? Trying to do the math in my head. So it's 4 bytes times 8 bits. So it's actually, sorry, 2 to the 32. There we go. So 2 to the 32 is, yes, 4 billion, something like that. But now keep in mind that the lowest integer value you can have is not actually 0. It's negative. So, because if you look at the minimum integer size, so C++ minimum integer value, it's negative 2,147,000,000, so on and so forth. So the number of values between negative 2 billion and positive 2 billion is about 4 billion different numbers that you have to work with. So all of this is basically getting to the point of the way that a computer represents in C++ specifically an integer is that it gives you this many -1. This is like the next number up. Different values that you can actually affect. Now, this sets a range on how large or small your integers can be, but more importantly, it also lets us know in the computer when we're setting up an array, how much space do we actually need? And how much space we need in the computer depends on the kind of variable we're using. The amount of space you need for a string is not going to be the same that we need for an integer. For example, if I were to try this out, let's actually do this for all of the types, just so we can, sate our curiosity. We need character, double, int, string, float. So let's do that in order. Character, double, int, string, and float. And let's try all these and see what they all look like. Oh, let's put a new line after each one so this doesn't look so messy. It's a little hard to read the way it is. Okay. So, a character just takes 1 byte because if you look at, for instance, the ASCII table, the number of values you have to work with in there is a fair bit smaller than 2 billion, or 4 billion. So you don't need that much data to represent a single character. There's only so many you have to work with. A double has basically twice as much memory required in comparison to an integer. A floating point requires the same amount as an integer, but if you remember from earlier in the class, we compared floats and doubles, and both of these had various amounts of issues with precision, with exactly how correct the numbers would be. For example, if you tried to store 2/3 into either of these variables, it's not going to quite give you exactly the right number, and that's limited by how much space we have in the computer to represent these values. Now, and string, you can see here, represents a whole chunk of data, 32 bytes for how much a string could be. So that means you could put in a lot of characters into that. Now, in our program, we want to figure out how long an array is, and these values are going to help us, and here's why. Let's set up some arrays, and what we're actually going to do, first off, let's comment, I guess we can leave this here. Let's set up some arrays, so we can steal this one, for example. We're going to make my string array, sorry, this is bad style, we should do this properly. My string array. This should also be my underscore. Let's try to use good style, right? It's probably a good thing to do in this course since we've now gone through style as a topic. Okay, so we got my string array, and we're going to do the same thing for all the other types. So string, character, double, int, float. So we have my double array, my character array, my integer array, my string array, and my float array. And let's try to get the size of each of these, just out of curiosity. So I'm gonna copy all this. So the size of this, the size of this, size of this. Not the most exciting programming ever, but you know, it has to be done. And here. Let's go see what these all look like. We'll put in another end line at the bottom here, just to space things out a little nicely when we look at the output. Okay. Let me double check what's going on here. Oh yeah, probably would help to change the types here. So this should be character, this should be double, this should be int, and this should be float. Let's try that again. These are all showing me the same number, which give me an indication that something I forgot. Okay, now look what's going on here, kind of interestingly. Each of these arrays holds 5 elements. As I said, you know, put 5 elements in there, please. But if you look at the size of each of these arrays, all the numbers are different. So my character array has exactly 5 bytes because each character is 1 byte and there are 5 of them, so kind of makes sense. My double array takes 40 bytes to store, and that's because each double is 8 bytes and I have 5 of them, so 40. And you know, so on. 32 times 5 gives me 160. Now, the reason that this is all super useful is because there isn't a built-in method that gives you the length of an array. In Python, you can do len parentheses list of whatever list you're working with, and it tells you how many elements are in there. In C++, things are a little bit trickier because arrays here don't actually have any methods to give you that information. So you have to do a little bit of math. Now, using size of on your array of whatever size it is gives you a number of bytes that represents how big the whole array is in memory, how much is being taken up by this whole thing. And if you take that number and divide by how large each individual element is, you know how many elements there are. It's, you know, size of everything divided by the size per element gives you the elements. So if you want to figure out how many elements are in any of your arrays and you don't know how many are there, it's actually not too difficult. All you have to do is use size of on your array and divide that by how many are there. So if I do that, we're going to make some really messy code here. I suppose we can make this next block look a little bit cleaner by spacing things down a bit. And so what we're going to do is we're going to take each of these and we're going to divide by the size of each element. So this is going to be divided by the size of the character. So you can divide it by the size of the double, divided by the size of an integer, divided by the size of string, and divided by the size of float. Let's give that answer. Finally, divide by size of string. Now, I don't know how order of operations works with the little triangles and division, so I guess we're going to find out, and if it doesn't work, I'll just have to throw in some parentheses. And look at that. The size of your character array divided by the size of each character gives you 5. The size of your double array divided by the size of the double gives you 5, and so on. So now we can calculate the number 5 based on the size of your character array, which you have the size of function, you have the character array, and you can get the size of the individual character and use these together to give you something that you may not know right away. For us, it's kind of easy. We can just see, oh, look, there's 5 of them, but you may be working with programs where the size of the array is not known to you right away, and this is a very important trick to help you figure out that answer. So there it is, and we can move on to our final exercise. All right, so last one. Multi-dimensional arrays where we're getting extra juicy. So let's make a new function here to put in the stuff we did from exercise 3. Since all of this. Okay, and let's go and make some multi-dimensional arrays. So the size is 3 by 2, and they're arrays of integers, and we're basically just going to add them together and store them in a new place. So int array 1, so this is going to be 3 by 2, and we need to set up the initial values of this thing. So the way that we're going to do so, there's, I guess, a couple of ways. One way you can do it is you can just write in each number. Another way that you can do it is you can do it by groups, which is the way I recommend doing it, just so that you can have kind of a better picture in your mind of what things look like. So inside your array, you have basically this 3 by 2 means you have 3 groups of 2 integers each. So group 1, group 2, group 3. And let's say that our numbers are, 1, 2, 3, 4, 5, 6. Okay, now my second array, also 3 by 2. Let's do, 7, 8, 9, 10, 11, 12. So if you were to picture this in your mind, there's a couple ways that you can kind of think about it. The way that I would recommend is probably the way that you would in mathematics. So you probably have something like this in your head. You have 1, 2, 3, 4, 5, 6. Something like this is basically the way that this first array is represented. And so if you were to do any kind of linear algebra with this, this is sort of the structure that this would look like. Now, I don't think that anybody watching this video will probably have much practice with linear algebra just yet, but probably in the next semester or in your next year, you will get to see problems where you have to actually do some mathematics with these kinds of issues. So it's good to be able to at least see how in coding we can actually generate these sorts of problems that you'll be using later on. If you do any work in like graphics, for instance, this is like a huge thing you definitely have to know. Now, we also need a third array. This is going to store our results. We don't have to initialize it though, because actually we should, because we don't know for sure if the values are going to be what we want them to be. So we're actually just going to set them all to be 0. I suppose this isn't necessary because we can just replace the values in here. Yeah, you know what? This is unnecessary. We don't have to do this. What we do have to do is we need to go through each element of these first 2 arrays, combine them, and put them into array 3. So to do this, we're going to need to use a nested loop, one loop inside of another. So for the 3 groups that we have, I less than 0, I is less than 3, I plus plus. So this loop is going to go through the 3 different groups that are here, and then for each group, we need to go through the 2 elements that are there. So for j equals 0, j less than 2, j plus plus, we're going to have array 3 at group I, element j, is going to be the sum of the elements from array 1 and array 2. And to make sure this works, we can actually just print it out as well. So C out element, and we'll put I j equals array 3 I j. Bit of a lengthy line, so maybe I'll make this look a little nicer and space that down. Tab that over. All right, so let's see what this looks like. So we have, so these 2 should be added up and give 8, 10, 12, 14, 16, 18. Those are all the numbers that we get. And we can see here the indices for each of those inside of our new array, which match what the indices are for arrays 1 and 2. So this nesting of loops is not something that we've had to do too much yet in this course, but is the kind of thing that actually will come up quite often, especially next week when we start talking about doing sorting. So knowing how a loop operates inside of another loop is something to get some practice with. Multidimensional arrays are a great way to do this because there really isn't a great way otherwise to access all elements of a 2D array unless you were using multiple loops. And if you really want more practice, try with three-dimensional arrays. What does a three-dimensional array look like? Essentially, you have groups where each group looks like this. So you might have one of these. So let's say I had two. Actually, it should be, so let's have two groups of 3 and 2. So you would have, let's add some extra braces around here. So all of this twice. So 2 groups of 3 groups of 2. And you can obviously build up from here if you really want to, but I don't think that anything beyond this is really necessary. In fact, three-dimensional arrays is probably more than you need to worry about, but if you ever want to practice it, it's not a bad idea. So that's everything for our video, and I will see you guys in class. Take care.